we're actually almost done with chapter 1. We have an exam coming up on September 13th, which is a Sunday, because remember assignments are always due either Wednesday or Sundays. I'm going to be posting the exam the Friday before. So what we're doing today is we're going to talk about conversions, and I have a video posted from Tuesday's class on conversions as well. So what I'm going to do here is I'll do a few more conversion examples. They're going to be different than Tuesday's class, so I recommend you watch the Tuesday video as well if you haven't. So we'll kind of do a review of conversions, a few problems with that, and then we're going to do percent error and density. And density is the last topic of the chapter. So we're basically finishing the chapter today, and then next week will be for review. So I'll talk about a little more specific on the exam, and then we'll just do examples on everything to kind of show you what you might see on the exam itself. But make sure you are doing your discussions. There's one new one every week. This week's discussion is on conversions. So you need to post or reply or put a video up, at least 2 things every week to get those points. And it's worth a total of 10% of your grade for all of them. So it's a big chunk. If you don't do any of them, you're already lost a grade, letter grade. So, all right. So let's get started with the actual problems themselves. So with conversions, there are 2 different types that we're going to look at. Okay. In a different chapter, we'll talk about temperature conversions, but for now, we're going to focus on English to metric conversions and metric to metric conversions. So English to metric conversions, we're going to find a conversion factor from our sheet, or you can find one online too if you'd like. And we're going to do a method that we call railroad tracks. Okay, so let's try one of these first. So looking at this problem, 0.150 tons is equal to how many kilograms? Okay, so your first step when you are approaching a conversion problem is what type of problem is it? Is it English to metric or is it metric to metric? So to figure that out, you just look at the units themselves. Okay, if it's metric to metric, the second type, you'll have a letter in common. Okay, so it'll be milligrams to kilograms, or centimeters to meters. You'll have a letter in common. In this case, we don't have a letter in common, so that tells me that it must be English to metric. Okay, so what we're going to do, since we now know it's English to metric, is find a conversion factor. Sorry, I think it's hard to talk in. So we're going to go to our sheet and see if there's a conversion factor that will get me from tons to kilograms. So you'll notice the conversion factor sheet is separated into sections. So we have length, mass, volume. So what we're doing now is kilograms and tons, they're both a mass. So that's the area you're going to want to look in when looking for the correct conversion factor. So is there one that goes directly from kilograms to tons? So I'm going to write CF for conversion factor to the side here. And I do see one. If you look at the second one down in the mass section, it says 907 kilograms is equal to 1 ton. Okay, so that'll get me between kilograms and tons. So English to metric, we have now found our conversion factor. The next thing we're going to do is start our railroad tracks. What I mean by that is basically like a plus sign. And what we're going to do with this plus sign is we're going to fill it with the original question and the conversion factor. So what's always going to go in this upper left-hand corner is what the question is asking you to convert, the number it's asking you to convert. So we're just going to put this 0.150 tons right here in the upper left-hand corner. Now what's going to go in this empty space is the conversion factor. And conversion factors are separated by an equal sign. So that allows us to write it as a fraction in 2 different ways. So we can write it with the kilograms on top, or with the tons on top. Okay, so these mean the same thing, it's just flipped. So we need to figure out which fraction form is going to help us solve. So imagine picking these up and setting them in this empty space here. And the one we want to pick is going to be the one that's going to cancel out the units we don't want and keep the units we do. Okay, so we're trying to cancel out tons. We're trying to get rid of it because we want our answer in kilograms. So we're going to pick this conversion factor because that fraction form puts tons in the denominator and kilograms in the numerator. And the reason we want this is because this horizontal line here, it's a division line. So if I have the same units on opposite sides of that line, I'm dividing them, and they'll cancel. So tons divided by tons is just going to equal 1, so those units cancel. So now the only units I have left are kilograms. So to solve, I said the horizontal line's a division line. Well, the vertical lines are multiplication. So we're just multiplying across what's on top and what's on bottom. So I'm going to take 0.150 times 907. And then I'm dividing that by 1. But anything divided by 1 is just itself. Just making sure to include that since that's what I have in the bottom. So what do we get for that? If anyone gets it before me, feel free to shout it out. Oops, Mike, I'm pushing the wrong buttons. I get 136.05. Anybody get something different? Helps to have someone check my work just because I do get them wrong sometimes because I press the wrong button and I'm trying to hurry. So this is not our final answer. Okay, so whatever your calculator spits out, you're not done yet. You need to count sig figs. That's why we learned about them last week. So to count sig figs, you're looking at the significant figures in the number given in the question only. Okay, so we're not going to worry about significant figures in the conversion factor we found, just the original question. So counting sig figs here, so this is a review from last week. We start counting at our first non-zero digit, the 1. The 5 also counts. Now, zeros sometimes count. Does this 0 count?
Yes.
Yes. Why?
It's a decimal.
Because of the decimal. So if there's a decimal present, as long as we already started counting, which we did, the zeros after the decimal will count. So we have 3 total sig figs. So now we go down here and we want 3 in our answer. So 1, start counting left to right. 1, 2, 3. So I'm going to stop there, look to the number next to it to see if I need to round up or not. In this case, no, right? So 136 is the correct sig figs. And last but not least, units, okay? So now we're doing calculations that include units, so we need to make sure we include our units. So this would be the correct answer. 136 kilograms is equal to 0.150 tons. All right. Some questions on that one? All right, so now we're going to try another one. See if I have one prepared. Okay, so this time we're going to take 550 milligrams and we're going to convert it to grams. So say you went to the doctor, you're sick, they gave you a 550 milligram pill of some kind to take. Because that's usually what they measure medicine in, is milligrams. Well, say you want to know how many grams it is, just for fun. So to figure that out, you have to look, what type of conversion is this? Is it English to metric or is it metric to metric? Because you're approaching them differently, so you need to know what type you're looking at. So to figure that out, you're looking for a letter in common with the units. And in this case, do we have a letter in common?
Yes.
Yeah, we do. And you can see that if you just say the words out loud, right? Milligrams, 2 grams. We even have a word in common. All right, so that tells me that this is a metric to metric. So I'm not going to go to my tables and try to find a conversion factor. That's not going to help me. It's actually going to be easier than that, because what I get to use when it's metric to metric is this scale here. And all I'm going to do is move the decimal. So there's no dividing, there's no multiplying, I'm just simply moving the decimal. So how do I know where to move the decimal, how many times, what direction? This scale here, okay? So what this scale is it's the prefixes in the metric system. Kilo, so you might have heard of kilometer or kilogram. Hecto, this is a very uncommon one, so you probably haven't heard of it. Same with deca. But then we have deci, centi, so like centimeter, and then milli, and that's what we're looking at now is the milli, right? Milligram. Okay, so we're going to use this scale to help us. Now, there are some mnemonic devices to help with this scale. King Henry died drinking chocolate milk, so just a way to help you remember the scale, because it's going to really help you with metric to metric. So I'm going to erase the names of the prefixes so that we can put this scale to use. Now notice it has a blank spot. Well, that blank spot is there because it's going to change depending upon the unit of measure that we're using. Okay, so what I mean by that is if we were doing length, right? Length is measured in meters in the metric system. So we would put an M there for meters. If we were doing time, well, seconds is what the metric system uses, so we would put an S there for seconds. But what are we doing? We're doing mass. So for mass, it's measured in grams in the metric system. So we're going to put a G here. Okay, so basically whatever letter is in common, that's the letter that's going to go in this empty space. Okay? So now we can use it. It's all ready to be put to use. Well, how do we use it? Okay, we're going to take and see what prefixes we need to go between. So we said milli, so milligram, and we're going 2 grams. So what that means is we're going to start at the M, the milli, and we're going to go to the G, grams. So to figure out how many times to move that decimal, we're just going to use each of these prefixes as a placeholder and count how many times. So to go from the M to the G, I'm going 1 time to get to centi, 2 to get to deci, and then 3 times to get to the grams. So I'm going to move that decimal point 3 times. What direction? The same direction that you just went. So I moved to the left, so that's what I'm going to do when I go over to the number. Let me write the number down here so we can see it a little bit more clearly. So this is the original number in milligrams. I just said I'm going to move it 3 times to the left so that I can convert it to grams. There is no decimal point in this number, so where do we start?
At the end.
The end of the number. We make one, right? That's where the decimal point would be if there was one. Now I'm going to take that decimal and move it 1, 2, 3 times to the left. It is now before the 5. So to write this number out, it's going to be 0.55. Now I need to figure out if I want to keep that 0 or not. Okay? To do that, you're counting the sig figs in the original number. So let's quickly count them. We know these 2 count because they're not zeros. Does this 0 count?
No,
No, why not?
there's no decimal.
No decimal. So no decimal this time, it does not count. So since it doesn't count, there are only 2 sig figs, and we don't want to count it in the answer so that we stay at 2 sig figs. Last but not least, put your units on it. So 550 milligrams are equal to 0.55 grams. Questions on this one? Now we're going to combine them and try a harder one, probably the hardest one you'll see in the class. I think there's even one like it on your homework, the homework quiz. So the chapter 1 homework quiz, I don't think that's due till Sunday, right? I think that's due on Sunday, and that's on significant figures in scientific notation, so you can take that now if you want. The chapter 2 homework quiz is on conversions, and that's due next Wednesday. All right, so 270 yards to miles. Let's try this guy. All right. First step, what type? English to metric or metric to metric?
English to metric.
English to metric, there's nothing in common, like no letter anyway. So what we're gonna do is look up a conversion factor. And you'll notice when you go into your conversion factor sheet, there isn't one that gets you from yards to miles. You actually only have 2 conversion factors that have yards in them at all, and both of them go to meters. So that's our only choice. So I'm gonna write that conversion factor down since it's the only one that has yards in it. And it doesn't matter which one you choose. They'll both get you the same answer as long as you're setting up the equation correctly. So this is the conversion factor that goes from yards to meters. So what that tells me, I'm gonna write a little plan here, is that I'm gonna have to go to meters first. Okay, so we're just gonna work our way through this. So using that conversion factor, I'll get from yards to meters. But obviously I'm not done because I want to get to miles. Now, notice I can't get from meters to miles. Does anyone see one to get to meters to miles?
No.
Do we have one with miles in it at all?
Kilometer.
Kilometers. Okay, so I'm going to write that down just because it's the only one we have with miles. So kilometers equal to 1 mile. Okay? So we can get from kilometers to miles. All right. Can we get from meters to kilometers? What's meter to kilometers? Is that English to metric or metric to metric? Meters to kilometers.
Metric to metric.
Metric to metric. So we could get there. So, and this is a lot of time just trying to play with it and figure it out. Can I do this? Let's see. So yards to meters, yes. We can use that conversion factor to get us between yards and meters. All right. So meters to kilometers or kilometers, depending how you say it. This is metric to metric. We can do that. It's not a conversion factor, but we can move the decimal point to get there. All right. Now the last step, once we're in kilometers, can we get to miles? Kilometers, miles, kilometers, miles. So this will get us there. Okay, so that's why this is the hardest one. It's 3 steps. This is the hardest one you'll see. So let's try it now. We have a plan. Let's put it to use. So our first step, we're going to take it step by step. So our first step is an English to metric step. So with English to metric steps, we're going to use a conversion factor and we're going to do the railroad tracks. So I'm going to start with my plus sign to do this first step. When I do my plus sign, what's going to go in this upper left-hand corner?
270.
270, the original number in the question. So I'm going to use the first conversion factor to get from yards to meters. So do I want the yard portion on the top or the bottom? Bottom. I want it to cancel. Remember, they need to be on opposite sides of the horizontal line so that the yards and yards cancel. That 1 meter then will go on the top, the 1 meter portion. So in this case, I'm dividing. All right, so when I calculate this out, I get 270 if I go across times 1 and then divided by 1.09. Now I'm not going to worry about sig figs till the very end. Okay, so no rounding until you get to the end of it. Is it a lot of numbers? Yes, it is. 247.7. I'm going to stop there. Okay, so now I'm in meters. Did you get something different?
Is it 706?
Could be. I could have entered it wrong.
I think it's 706.
270 divided by 1.09? 7064, thank you. Is that what you meant?
Yes.
Okay, thank you. All right. So we're in meters. To get to kilometers, we're going to do the metric to metric. So now we're skipping over here. Okay, metric to metric, we're using the scale. We're not using a conversion factor. So this time, what's going to go in our empty space? If we're measuring length, so it's going to be meters. I'm going to put an M here. Not to be confused with this M. Remember, this is millimeters. And then this middle M is meters. So we want to go from meters to kilometers. So we want to go from the M to the K. So we're going to do the same thing we did before. How many times do we need to move the decimal? 1, 2, 3. What direction? We moved to the left when we did it. Okay, so start at the decimal and let's move it. 1, 2, 3. That's going to get me 0.2477064. Kind of hard to keep all that. Now my units are kilometers. So I'm almost there. I'm here. 2 steps done, 1 to go. Notice my last step, I'm in metric and I'm going to go to English. So metric to English, I'm going to use a conversion factor, which we already found, and I'm going to use the railroad tracks. So my railroad tracks, this is what I would start with, so I can just draw it around it. And then the second conversion factor is what's going to go here. And I just need to figure out how. What goes on top, what goes on bottom. So where do we want the mile portion? Numerator or denominator?
Numerator.
Numerator, because that's what we want to keep. That's what we want our final answer in. And then the kilometers will go in the denominator, which is good, because that will put those units on opposite sides of the horizontal line, thus canceling. So I'm going to take that big long number and divide it by 1.609. I still have it in my calculator. Another big number. Okay, I did that calculation wrong. It should not be that. What did you get?
No, that's a long number, 0.15395.
Wait, say that again, sorry, point.
0.15395.
Okay, that's good. Because we're going to do sig figs, and you know we won't go further than that. I entered something wrong because I got a whole number. So this is why I need other people doing the calculations for me. So the reason we stopped there and didn't write all the numbers is because we're going to look at the sig figs, and we won't need more than 5. We know that. So let's go back all the way back to the original problem way over here and count the significant figures of the original number. So if it's non-zero, they matter. Does this 0 count? No, it's like the last problem. There's no decimal point, so the 0 doesn't count. So we have 2 sig figs. So we're going to go over here and count 2. So 1, 2. Look to the number next to it. Does that stay a 5 or do we round up?
Stay at 5.
It stays a 5 in this case. I can't write that way. I have to go over here. So it's just 0.15. And then our units in the very end is miles. So 270 yards. So say a football player was supposed to run 270 yards. That means they only ran 0.15 miles. Looks like a lot less that way. So most of the conversion problems that you'll see in the homework quizzes, on the test, will just be one step. Okay, so there might be 1, maybe 2 that involve multiple. For the most part, it'll just be one step. So if you want to see more problems, watch the Tuesday video. I do the whole period. I'm doing conversion problems on that. But what we're going to do is move on to percent error. So percent error, if you are taking lab this semester, we're going to use it a lot in lab. probably get maybe one or two on the homework and exam. But you won't see it a lot in this course, mainly for lab. So the reason experimental error is used in lab is because we're basically trying to figure out how close we were to the value we should have got. Because when we're in lab, we're trying to replicate experiments that have already been done. And so we know what we should get, and we're seeing how good our technique is, how close we actually were. So I'm going to go ahead and write the equation, percent error. And there's several different ways to write it. So your lab manual might use different words than I did. Okay? The PowerPoints might have different words than I did, but they all mean the same thing, and that's what we're going to talk about when we approach this word problem. So I'm going to write the word problem down, and we'll talk about the different words that are used when representing this equation and what those words mean. All right, so say we have a student. All right, so you go into lab, you measure the density of water by taking the mass of it, taking the volume, and you get 0.915 grams per mil. But the actual density, the test proven density, is just 1 gram per mil. So we're going to calculate the percent error. We're going to see how far off we were. Excuse me a minute, throat's getting dry. All right. Don't want to start coughing and scare people. So let's look at this. We have two numbers. One of those numbers is going to be the measured. The other number is going to be the true. So how do we figure that out? Well, the measured is the experimental. It's usually what the student or scientist did. That's how you figure that one out. So, which one of those numbers is the one the student did? The first one. So I'm just trying to give you clues to figure out which number is which so that we can plug it into the correct spot. Because it's really just a plug and chug problem. Once you know which number goes where, you just insert it in the equation. So for the true value, words you'll see for this are theoretical. Oftentimes, because theoretical just means proven. Proven value, it's often the value that you get from a table. In this case, by default, it's the other number. But, actual is also used. That's a good one. Actual value. That's what we used here, right? The actual density, the true density, the proven density, the density I found in a table is 1. Okay, so now we know which is which. Let's put them in the equation. Okay, so I'm going to erase this so we can plug them in right below it. So, our measured 0.195 is going to go here. We're going to subtract our true, the 1, and then divide by the true, which is 1 gram per mil in this case. Don't forget to multiply by 100. That's what makes it a percent. Now, before we calculate this, I want to talk about some features with this equation. So notice the top part has bars. They're not parentheses, they're bars. Those are absolute value bars. So if you happen to get a negative when you subtract these, which we will in this case, absolute value means it should be positive. So just change that negative sign to a positive sign. You're not altering the numbers at all. You're literally just changing the negative to a positive. So when I subtract these two, I'm going to get a negative number because 0.9 is less than 1. So just change that negative to a positive, then you will divide it by 1, and then multiply by 100 to see your percent. So we're figuring out how close we are to the actual value. You should never get a negative percent error, is what I'm saying. I got 8.5%. Anyone get something different? So he was 8.5% off of the true value. And there's another percent error problem in the PowerPoints that you can work through if you wanted more practice with these. But the main thing is just figuring out which is which one's the true, which one's measured, and plugging it in correctly. Questions on percent error? Right. So this one was a short one because it was just that one equation. We're going to look at density next then. Density is the last topic of the chapter. Density, we have an equation for that as well. It's going to be mass over volume. So often represented just D equals M over V. So those are the variables that we use to represent density, mass, and volume, D, M, and V. Now for the mass, in this course, it's going to be measured in grams. So that's the units on it. For the volume, we're going to have it in milliliters. And we saw that actually in the previous question, because we were talking about density of water and what the density the student measured. And when we saw the units on density, so that's what we're looking at next, the units on density were then grams per mil. Because if mass is in grams and volume is in milliliters, our units would be grams per mil. So that's where we get that from. So volume measured in milliliters, sometimes we will see it also in centimeters cubed. These are interchangeable, these units. They're equal to each other. The reason we sometimes use mils and sometimes centimeters cubed is because if it's a volume we're measuring, we're going to get out a graduated cylinder. We're going to pour liquid in it and we're going to measure it in milliliters. But if it's a solid that we're measuring, we're not going to be able to pour that into a graduated cylinder. Instead, we're going to go get a ruler and we're going to measure it in centimeters and we're going to do a calculation to calculate its volume. So if we do a solid, it's going to be centimeters cubed for the volume. And we'll see that in lab, I think, in 2 weeks when we do that one. All right. So that's why we also have sometimes density is grams per centimeter cubed instead of grams per mil. So I just want to point this out so you don't get thrown through a loop if you see it this way. They're exactly the same. All right. So let's look at a word problem and try to apply this equation to it. Okay, so we're going to start with a straightforward one where we're solving for density. And then we'll try a few others where this equation is going to need to be rearranged. And I have a trick for that that will help you rearrange the equation if you need to. So let's start off the more straightforward one. So we're going to calculate density of a 5.0 solution. Volume of starting off with word problems. Starting in chapters 2 on up, we are going to be doing a lot of word problems. And word problems is mainly trying to figure out what the numbers represent. So here we're calculating density. Okay, so density is what we're looking for. So I'm going to put D with a question mark because that's what it's asking me for. So what I need to figure out next is this 5 grams. What is that? Is that density, mass, or volume?
Mass.
It's mass. Okay, it doesn't explicitly tell you it's mass, but how do you know? Grams, the units, right? We just said mass is measured in grams. So if I see a gram amount, I'm going to say that's a mass. Now next, it says solution that has a volume of. So it's telling us that this is the volume. But if it didn't tell you specifically that that was the volume, you could figure that out as well based off of the units, because it's milliliters. So now all we need to do is use the equation and plug in our information. Put mass on top, volume on bottom. Now I know this seems like a lot of extra steps, but when we get into the later chapters, there's going to be a lot more variables. So it's good to get in the habit of like writing down your knowns and picking your equations, because we're going to do a lot of that in the next chapter. So 5 divided by 7.3. And I notice I put the units there. I'm just trying to keep track of them. So what do we get when we divide those two? 0.68.
Or do we only need 2 sig figs?
You do only need 2 sig figs, yes. So you already rounded it for me. Is that what you're saying?
Yeah.
Okay, so 0.68. So he's looking at sig figs here, right? Because that's what you have to go back to. So you count the sig figs in both the numbers you used. 2 there, 2 there. So I only want 2 in my answer. Okay, because remember, we're dividing, and when we divide, we're looking at sig figs as a whole. It's addition and subtraction, we just focus on decimals. So I have 0.68 as my answer, and I want to remember units. So since it's a density, I'm going to have grams per mil. All right. So now, that's the most straightforward. That's the easiest density problem you're going to see. So we're going to look at a couple harder ones because they're not all that straightforward. So to do that, I'm going to use this guy. So this is called the density triangle, and you just fill in the variables in this triangle. GMB. GMB. So we're going to use this to help us rearrange that equation. Because the next problem I put up here, we're going to need to rearrange the equation. We're not going to solve for density, we're going to solve for either mass or volume. So let's start with volume. So what volume? So 10.2 grams. All right. So this time, what volume will 10.2 grams of benzene occupy, and it gives us the density. So I'm going to write down what I know. So what is that 10.2 grams? Is that a volume, mass, or density?
A mass.
Mass, we know it's the grams. So the density, they told us specifically it was density, but if they didn't, the grams per mil would have gave that away. So we have these two variables, the M and the D, and we're looking for V. We're looking for volume. So we're going to have to rearrange this to solve for volume. And this is just a quick way to do it with this triangle. So it's just like with the railroad tracks. Horizontal lines is the division line. Any vertical lines are multiplication lines. So to use this to rearrange the equation, you look at what you're trying to solve for. So we're trying to solve for volume. So whichever one you're trying to solve for, you cover that one up with your hand. And then you apply the order of operations to the remaining variables. So if I'm solving for volume, I cover that up. And that means I'm going to take my mass and divide it by my density to solve for volume. So volume is going to be mass divided by density. So this is my new rearranged equation that I'm going to use over here. Once you have it, simply put in the numbers. So you have 10.2 grams, the mass on top, 0.879 grams per mil, the density on bottom. And then notice, if you put your units in here, grams are on opposite sides of that horizontal line, so they cancel. And that's good because we're solving for volume and the only unit left is milliliters, and that's what we want our units in. So when we divide those, we already said the units are going to be mils, what do we get for the answer?
11.6.
11.6. And you already did the sig figs, it looks like? No? That is the correct sig figs though. Because you're looking at the original numbers. We have 3 sig figs here. And we also have 3 here. So you usually pick the smallest, but since they're both 3, we still want 3 in our answer. So 11.6 milliliters will be the volume of that 10.2 grams. Questions on this one? All right. Well, let's try it again, but with mass. So, where's the mass? Density. All right, so this time we're going to do ethanol. So ethanol, also known as ethyl alcohol, so it's grain alcohol. We have the density of it here, and we're going to calculate the mass of it if we are given a 30 milliliter sample. Okay. Before we do this one, I'm going to take a different approach, and I'm going to count the sig figs first, just so we can. A lot of people like to do that so they don't forget about it at the end. So the reason I can do this first is any numbers included in the question, I can just count their sig figs, and the lowest number will be how many sig figs I want my answer. So 0.789, this one's a pretty easy one because they're all not 0, so they all count. But what about 30.0? We know the 3 counts, but do the zeros count?
Yes.
Why? Decimal, exactly. We start counting at the 3, and so since there's a decimal, any zeros after the 3 will count. So it is 3 sig figs. Good. A lot of people like to want to say 1 on that one. All right. So, what are we solving for in this one? Density, mass, or volume? Mass, right. So that's our question mark. So by default, that means that this number must be a volume. And if you weren't sure, you're going to look to the units to figure that out. Since it's milliliters, that's how I know it's a volume. So I'm going to rearrange this equation this time now to solve for mass. So I'm going to cover up the m since that's what I'm looking for. So that tells me to solve for mass, I'm going to take density and multiply it by the volume. Density times volume. And just plug them in. 0.789, that's grams per mil, times 30 milliliters. And notice once again, milliliters are canceling. Okay. Which is good, because mass should be in grams. So 3 sig figs, what do we get for the answer?
23.7.
Trust that you rounded correctly?
Yeah.
Yeah. just double checking. So 23.7 grams. So if we were to mass that 30 milliliters, what would show up on the scale would be 23.7. Different things weigh different amounts depending upon their density. All right, I have one more for you. It's going to combine conversions and density together. So this next one that we're about to do will be one of the harder density problems you'll see. I always like to save the hardest one for last. Work our way up. All right, let's look at ammonia. Alright, so, same type of problem, we're still talking about density. So in this one, we have ammonia is the chemical compound we're talking about, and the density of ammonia, very, very small density. Okay, so it's 0.000771 grams per mil. We're going to calculate the mass of a 6-liter sample. Let's do the sig figs first again. So density, where do I start counting? What number?
First zero, or not the very after the decimal.
You want me to?
No, wait, never mind, because you don't start counting.
We don't start counting yet. So we start counting at our first non-zero number. So what's the first non-zero number? 7. Right? So a lot of people want to start counting here because they see a decimal and they think, decimal, zeros count when there's a decimal. Yes, they do, but only after the first non-zero number. So we're not going to start counting till the 7. So we have a 7, a 7, and a 1. So 3 sig figs there. Okay. The next number, well, we know the 6 counts. Does the 0 count? Yes. So we started counting at the 6, and there's a decimal, so any zeros after the 6 will count. So 2 total. So how many sig figs in our answer? 2 or 3? 2. Pick the smallest, always the smallest. So once we're done, we're going to double check our sig figs and make sure we just have 2. Okay? So now, let's do the problem. See what we get for the answer. So we have a density, it specifically says density of, write that down, grams per mil. And then what is the mass? So mass is the question mark. Saying what is. So that means this 6.0 liters. So notice it's in different units. It's in liters, and we've usually seen it in milliliters. Okay? It's still a volume because it's metric and metric, right? Milliliters, liters, those are both metric. So this 6 liters is still the volume, but we can't plug it into the equation when it's in liters because we have liters here and milliliters here. So there's a separation there. So our first step is going to be to convert this volume to milliliters. We need it in the same units that the density has it in so that we can, before we can put it in the equation. Okay, so I'm going to go over here and do that. Kind of a side thing. So we're going to convert 60 liters to milliliters. I use a different color for that, just for fun, I guess. So when you're converting, is it English to metric or metric to metric?
Metric to metric.
Metric to metric. So we just have to move the decimal. So to figure out how many times, we're going to look up our prefixes. That King Henry died, space, drinking chocolate milk. Okay, what's our base? What's the letter in common here? Liters, L. So that's what's going to go there in that empty space. So we're going from L to the M. So go over here from L to the M. So now we just need to move the decimal. How many times? Start at the L, and go once, twice, 3 times. What direction did we go? This time we went to the right, yeah. So I'm gonna write the number down here so it's a little bit more clear to see. Starting at the decimal, I just said 3 times to the right. So 1, 2, 3. What's gonna go in those empty spaces?
0.
Zeros. So it's gonna be 6,000 milliliters. Now, we're not worrying about significant figures until we get our answer, okay? So I know this isn't the same significant figures, but this isn't my final answer, so it doesn't matter. We'll worry about that at the very end. So I have now converted this. It is equal to 6,000 milliliters. So this is the volume I want to insert in the equation. Since we're solving for mass, we figured out the rearranged equation for mass in the last problem. So we use the same equation. Take the density times the volume. So mass is going to be equal to the 0.000771 times 6,000. And we want 2 sig figs. That's what the answer.
It's 4.626. That's good.
4.626 on your calculator, and we just wanted 2. So 1, 2. Go to the number next, so that's going to stay a 6. 4.6, and then the units on it. What are we dealing with? Mass?
Yes. Grams.
Should be grams. Good. So the takeaway here is when you're looking at your numbers, figuring out, whether you're multiplying, dividing, how the equation looks, pay attention to the units, okay? Because in order to put these numbers in the equation, the units need to be the same, okay? So make sure it's always in grams, always in milliliters. Questions? No? So 20
So
minutes
even though we changed the number to 6,000, it's still based on the numbers in the problem?
Can you ask that again? So I
Like-
had to convert this to 6,000, so it was in milliliters.
Yeah. So the significant figures don't change to 6,000, it just stays what the number was in the problem?
Right, so I didn't worry about significant figures only because I only have to worry about them in my final answer. If I worried about the significant figures here, I'd still need 2, right? Because I just did a conversion on this number, so I need 2 sig figs. The only way to represent this number with 2 significant figures is to put it in scientific notation. So I would have had to, let's convert it to scientific notation for practice. Scientific notation says you need 1 non-zero number to the left of the decimal, right?
Yes.
So my decimal would be between the 6 and the 0, right?
Yes.
So I would have 6 point, and since I need 2 significant figures, I would have wrote 6.0, okay? Well, what would my exponent be? It's how many times you move the decimal point, and we would have started at the end, right? So how many times?
3.
3, and then since the number was greater than 1, it would have to stay a positive 3. So this would be our only way to have 2 significant figures. So I didn't want to go off to this tangent
Okay.
because it doesn't matter until the final answer. So if this was the question in its entirety, this is how you would have had to write it to get the correct sig figs. Because there's no way, you can't add a decimal point at the end because then you would have had 4. So that's one of those hard ones.
So basically, like in word problems, you just want to make sure that you work towards having units that you cancel out, I guess.
Yes, yeah, exactly. So you can look at them like conversions almost too, instead of rearranging the equation. You know what I mean? Because with the conversions, that was our goal. put it so that you're canceling units out. And that's what we did here, because we had, I'm just gonna write the units. The density was in grams over milliliters, and we multiplied that by the volume, right? Density times volume, which was in milliliters. So we were just looking to cancel out the milliliters so that we had grams left. And that's all we did. And we're going to be seeing a lot of that in the upcoming chapters. We're going to have word problems where there are several different variables. There's going to be velocity, acceleration, times, distance. There might be all four of those in one question. And you're also going to have a list of equations. Right now, we only have one possible equation, the density equation. We might have to rearrange it, but there's just one possible. Well, we're going to get to the point where you have 5 or 7 that you have to choose from. So that's why I start making these lists here, because in those more complex problems, making the list is going to help you look at the equations and be like, oh, this one won't work because I don't have that variable. Or this one won't work because I don't have that one. So you're going to have to do a lot of narrowing down. So this is just getting in the habit by listing the variables and their amounts, what you're trying to solve for, checking units. This is all stuff that we're going to carry into the next chapter. So it's just the introduction of it. But, so for the exam, you'll have scientific method problems, just like on the PowerPoints, if you watched those, where I'm basically going to give you a scenario and you need to tell me what part of the scientific method that scenario applies to. You know, when we talked about that in class, examples I gave, or if you, maybe if you were touching 2 different plants and they had different textures, what is that? So touching would be a observation. Yeah, you had it. So things like that. So that's what you're going to want to study when it comes to the scientific method, is more, okay, if I have a scenario, what step would that be? And then significant figures, like we use that for all the problems. So know how to count them, know how to use them in calculations. Scientific notation, we just did one here, but it's being able to go back and forth. And a lot of people have calculators that just do that for them. Okay, so know how to count significant figures in scientific notation. Conversions is where most of the problems are going to be on. So I did on Tuesday's class, that's what we did for the entire hour and 10 minutes, or just tons of different conversions. So today was kind of a short review of conversions. And then you'll have experimental error and density problems. So we spend a lot of time on this chapter because it's our base. It's what we're going to be using and bringing over in every other chapter. We're going to count significant figures for every word problem we do. We're going to use scientific notation throughout the rest of the chapters. So that's why this chapter is a little more leisurely. We just want to learn, really learn it in our heads. So that comes second nature. Any other questions? I can do another problem. We have 10 minutes left. Make them up. But yeah, so your Tuesday, Thursday class. So my Monday class doesn't have a class. So you guys kind of get an extra class before the exam. So it's just, you'll have 2 essentially review days where my other class will just get 1. But, so you get extra time. So I don't have the test made yet. I mean, I have a word question bank ready, but I'll let you know the exact amount of questions and all the details next week on the exam. Over the weekend, look for a practice exam. I always post a practice exam with answers for you to work through so that you can see where you're at, what you need to focus on studying, things like that. So you've learned enough to do the chapter 1, part 2 homework quiz. So there's 2 homework quizzes for this chapter. The second one is on conversions and density.